In this video, I will demonstrate my product which I labeled SensePack. SensePack is a room monitoring Arduino-based system which monitors in real time environmental factors such as room light intensity, temperature, and humidity, and can also provide current sensing. It features a light-dependent resistor for measuring the lux level or light intensity level, a DHT11 sensor to measure the temperature and humidity, and also an ECE5000 to measure the load current. It then uses software LabVIEW, which is a graphical user interface which can provide a front panel with indicators that can display formatted values being recorded by the sensors and sent by the Arduino. I will now present to you the different sensors and how they work. So to start off, we have the ECE5000, which is a Hall effect based sensor that measures both AC and DC current by detecting the magnetic field generated by the current flowing through its coil. So in this product, the 5 amps version is used, which outputs an analog voltage centered around 2.5 volts at zero current. The sensor's sensitivity is approximately 0.185 volts per amp, meaning that any deviation from 2.5 volts corresponds directly to the current passing through it. And since it's a very small signal, very small current, it is easily affected by noise. So to counter that, a moving average filter has been implemented, and it makes so that over 10 consecutive readings, it can provide a stable and reliable current measurement. So to simulate a load, for now, the ACS is wired in parallel with an LED in series with a 100 ohm resistor in such a way so that it should now provide a current of around 15 milliamps, 15 to 2 milliamps, as you can see on the screen. And this could be used in another system, maybe a bigger electrical system, to measure faults, to detect faults, and also short circuits. Next on, we have DHT11, which is a pretty basic sensor that measures both temperature and humidity using a single wire digital protocol. So when the Arduino sensor starts signal by pulling the data line low for at least 80 milliseconds, the DHT11 responds with a 40-bit data stream that includes integer values for temperature, typically within 0 to 50 degrees Celsius, and humidity for roughly around 20% to 80% or even sometimes 100% relative humidity index, along with a checksum to ensure data integrity. So despite its lower resolution compared to more advanced sensors, the DHT11 is ideal for simple environmental monitoring tasks and provides reliable readings, which are then transmitted to LabVIEW for real-time visualization. So now to show you how it works, this is the DHT11 next to the green LED. Right now the base levels for temperature and humidity are 24.8 and 47% respectively, and I will try to increase both at the same time using my hand. And since skin is very humid, the humidity should go up by quite a lot. So as you can see with my hand alone, the temperature has gone from 24 to almost 27, and the humidity went up to 91%. With my hand off now, these values should go down slowly. especially for humidity, as the moisture is evaporating from the sensor. These values are updated every 2 seconds by the Arduino, who then transmits everything through serial data connection to LabVIEW. This is around 1 minute after removing my hand from the THT11, and as you can see, both values have gone back to their base levels. Moving on to the last sensor, which is the LDO, which I'm showing here. So the light dependent resistor in SensePack is used to measure ambient light levels. Its resistance decreases as the light intensity increases. So the LDO is wired in a voltage divider circuit with a 10 kilo ohm resistor, and the varying resistance is converted into a variable analog voltage, which the Arduino reads from one of its analog pins. The raw value from the analog to digital converter, which ranges from 0 to 1023, is then mapped to a percentage scale. So the value that you can see here is a percentage. This setup allows the system to detect changes in ambient lighting conditions, triggering actions such as turning on this green status LED here when the light level drops below a certain threshold. For this product, the threshold for the light intensity is 50%. So whenever the light level drops below 50%, the status LED should turn on. Now to show you how it works, right now the base levels for the light level is around 78%, and if I shine a light on it, it went up from 78 to 97. And if I turn off again, it goes back to 78, 79%. Now, again, when the light level drops below 50, the green LED should turn on. So to show this, I will cover the LDO with my hand. So the light level went from 78 to 2%, way below 50. And as you can see, the green LED is now on. Now to show this again, turned off base levels. And if I cover it, drops way below 50 and the green LED turns on. Now, SensePack's versatile design allows it to be used in a variety of applications where monitoring environmental conditions and electrical load is valuable. For example, it can be used in a smart home automation system, such as it can measure indoor temperature, humidity, and lighting to optimize, for example, HVAC systems, adjust smart lighting, or even trigger window shades, ensuring comfortable living environments while improving energy efficiency. It can be used in greenhouse monitoring system, so such as in agriculture, it can track temperature, humidity, and light levels to help maintain optimal growing conditions for plants. Integrated with automated control systems, it could adjust ventilation, irrigation, or supplemental lighting to maximize plant health and yield. SensePack can also be used in industrial environment monitoring, as it can be deployed in factories or warehouses to continuously monitor ambient conditions. For instance, it could ensure that sensitive equipment operates within specified temperature and humidity ranges, or detect abnormal current loads that might indicate electrical faults. It could also be used in education and research labs. So in universities and research facilities, they can use SensePack for hands-on learning or experiments in environmental science and electrical engineering. It provides real-time data logging and analysis, which is valuable for experiments involving climate control or power consumption studies. It could even be taken to a larger scale on small city infrastructure, with multiple, if we use multiple SensePack units, which could be integrated into a network for urban monitoring, providing data on environmental conditions in public spaces, and aiding in urban planning or resource management. SensePack is designed with a modular architecture that makes it highly scalable and adaptable. Its user-friendly interface on LabVIEW not only displays real-time data, but also allows for easy data logging and further analysis. This feature makes it ideal for applications where historical data trends are essential for decision making. Additionally, it is cost-effective and portable, meaning that it can be deployed in various environments, again from academic labs to industrial settings, without requiring significant infrastructure changes. Its compact, professionally labeled packaging and dedicated power supply ensure that the system is both reliable and ready for practical use. Furthermore, its open design facilitates future upgrades. For example, it can be easily integrated into a larger IoT network, allowing for remote monitoring and control. The modular hardware design also permits additional sensors to be incorporated if needed, expanding its capabilities beyond the current parameters. And with its robust construction and straightforward calibration process, SensePack is not only a current solution for environmental monitoring, but also a platform that can evolve with changing needs and technologies. Thank you for watching.